like it's getting angry.
The water spout from the fire.
The birds are actually caught in it.
They are, aren't they?
I think so.
Are you getting all this?
Yep.
Look at that. It's going to be gone.
This isn't CGI. It's a tornado forming over the ocean in real time. What you're watching is called a waterspout, and it's one of nature's most mesmerizing phenomena. But here's what most people don't know. These ocean tornadoes are happening far more often than you think, and the science behind them is absolutely fascinating. Today we're diving deep into the real science of waterspouts, how they form, how powerful they really are, and why weather scientists are tracking hundreds of them every single year. By the end of this video, you'll understand exactly what causes these ocean tornadoes and why they're actually much more common than their land-based cousins in certain parts of the world. So let's break down the science, separate fact from fiction, and explore one of meteorology's most incredible displays of atmospheric power. First things first, what exactly is a waterspout? Simply put, it's a rotating column of air that forms over water instead of land. Think of it as a tornado's aquatic cousin. But here's where it gets interesting. Not all waterspouts are created equal. There are actually two distinct types. The first type, and the one you're most likely to see, is called a fair weather waterspout. These form directly over the water on relatively calm days, and they're the most common type by far. The second type is a tornadic waterspout, which is essentially a regular tornado that either forms over water or moves from land onto water. These are the real powerhouses, and they're much more dangerous. For this video, we're focusing primarily on fair weather waterspouts because they're far more frequent and their formation process is uniquely fascinating. But we'll touch on tornadic waterspouts too, so you understand the difference. Now, let's get into the really cool part. How do these things actually form? The process is like a perfectly choreographed dance between water, air, and temperature. It all starts with warm water. When ocean or lake water is significantly warmer than the air above it, something magical happens. The water heats the air directly above its surface, causing it to rise rapidly. This is called convection, and it's the same principle that makes hot air balloons float. But rising air alone doesn't create a waterspout. You need rotation. And this is where things get fascinating. As the warm air rises, it creates an area of lower pressure at the water's surface. Surrounding air rushes in to fill this void. And because of Earth's rotation and something called the Coriolis effect, this rushing air starts to spin. Initially, this rotation is happening horizontally, almost parallel to the water's surface. But as more warm air rises through the center, it stretches this rotating column vertically, like pulling taffy. This stretching intensifies the rotation through a principle called conservation of angular momentum. The same reason figure skaters spin faster when they pull their arms in. As this column continues to stretch upward, it eventually connects with the cloud base above. And now you have your waterspout, a visible funnel of condensed water vapor extending from the cloud down to the water's surface. The visible funnel you see isn't actually water being sucked up from the ocean. That's a common misconception. It's water vapor in the air, condensing because of the lower pressure inside the funnel. Think of it like the cloud that forms when you can see your breath on a cold day. However, spray from the ocean surface does get lifted and can make the bottom portion appear more water-like. So, what conditions create the perfect waterspout factory? There are three key ingredients. First, warm water temperatures, typically above 80 degrees Fahrenheit or 27 degrees Celsius. This provides the energy source. Second, cooler air aloft. When cold air moves over warm water, you get that strong temperature contrast that drives convection. The bigger the temperature difference, the more vigorous the rising air. And third, high humidity and low-level wind shear. You need moisture in the air to make the funnel visible, and just the right amount of wind change with height to get that initial rotation started. This is why places like the Florida Keys, the Mediterranean, the Great Lakes, and Australia's coasts are waterspout hotspots. They have warm water bodies near land where cooler air masses frequently pass over. Quick pause. If you're finding this fascinating, do me a favor and hit that like button. It really helps spread this content to other science enthusiasts. And subscribe if you want more deep dives into weather phenomena explained in plain English. Okay, back to waterspouts, because we're about to talk about their power. Let's talk about power. How dangerous are waterspouts really? Fair weather waterspouts typically produce wind speeds between 50 and 80 miles per hour, though they can reach up to 100 miles per hour at their peak. To put that in perspective, that's equivalent to an EF0 or weak EF1 tornado on land. Now, tornadic waterspouts, those are a different beast. Since they're actual tornadoes, they can pack winds exceeding 200 miles per hour and cause devastating damage if they come ashore. But remember, these are much rarer than fair weather waterspouts. For boaters and coastal residents, even fair weather waterspouts demand respect. Wind speeds of 60 to 80 miles per hour can easily capsize small boats, damage vessels, and cause injuries. And while they typically dissipate quickly when they hit land, usually within minutes, they can still cause damage to coastal structures, flip cars, and tear roofs off buildings. The good news? Waterspouts are generally much shorter-lived than land tornadoes. Most last only 5 to 15 minutes, though some can persist for up to an hour under the right conditions. Waterspouts don't just suddenly appear. They go through 5 distinct stages, and if you know what to look for, you can actually watch one develop from start to finish. Stage 1. Dark spot formation. A circular, light-colored disk appears on the water's surface, surrounded by a darker ring. This is the area where air is converging. Stage 2. Spiral pattern. You start to see a spiral pattern of light and dark bands winding outward from the dark spot. Wind is now rotating at the surface. Stage 3. Spray ring. A dense ring of sea spray, called a cascade, forms around the dark spot. This marks the most intense part of the circulation. Stage 4. Mature waterspout. The funnel is now fully developed and visible, extending from the water surface up to the cloud base. This is peak intensity. Stage 5. Decay. The funnel begins to become distorted, tilted, and eventually dissipates. This usually happens when the waterspout moves over colder water, encounters different wind patterns, or moves on shore. Understanding these stages is crucial for mariners and coastal observers. If you spot stage 1 or 2, you know to get to safety because a mature waterspout could form within minutes. Here's something that surprises most people. Waterspouts are incredibly common. We're not talking about a rare phenomenon you'll never see. These occur with remarkable frequency. The Florida Keys alone report over 500 waterspouts per year. That's more than 1 per day on average. The peak season runs from May through October, with July and August seeing the highest activity. Worldwide, thousands of waterspouts form every year. The Great Lakes region sees hundreds annually, particularly during fall when cold air masses move over the still warm lake water. The Mediterranean Sea, particularly around Greece and Italy, is another hot spot. In fact, waterspouts are far more common than land tornadoes in many coastal regions. The United States sees about 1,200 tornadoes touch down on land each year. But when you add up all the waterspouts along our coasts and over the Great Lakes, the numbers are comparable or even higher. The reason you don't hear about most waterspouts is simple. They occur over water, away from population centers, so they don't make the news unless they're particularly dramatic or come ashore. And now for the really spectacular part. Under the perfect conditions, you don't just get one waterspout, you can get multiple waterspouts forming simultaneously. This happens when a line of instability moves across a large body of warm water. Each area of rotation can spawn its own waterspout, creating an almost surreal landscape of multiple funnels dancing across the water. Some of the most incredible documented cases show 5 or more waterspouts visible at the same time. Imagine being on a boat and seeing this spectacle. It's both terrifying and absolutely mesmerizing. These multiple spout events are actually more common than you might think, especially in the Florida Keys and the Mediterranean during peak season. Weather enthusiasts and storm chasers specifically travel to these regions during summer months, hoping to witness and document these events. So how do we track and warn people about waterspouts? Organizations like NOAA, the National Weather Service, and Coast Guard stations maintain constant monitoring of conditions favorable for waterspout formation. Weather satellites and radar systems can detect the atmospheric conditions and cloud patterns associated with waterspout development. When conditions are right, marine warnings are issued to boaters and coastal residents. These warnings specifically mention the waterspout threat and advise small craft to seek harbor. For those on the water, the best safety advice is simple. If you see a waterspout or the conditions for one forming, move perpendicular to its apparent path. Most waterspouts move relatively slowly, around 10 to 15 miles per hour, so a boat can usually outmaneuver them if action is taken quickly. Never try to get closer to a waterspout for a photo or video. The risks simply aren't worth it. So there you have it, the real science behind waterspouts. These ocean tornadoes are a perfect example of how the fundamental laws of physics and thermodynamics create one of nature's most spectacular displays. From the warm water providing energy, to the cooler air triggering convection, to the Earth's rotation contributing to the spin, every element plays its part in creating these magnificent columns of rotating air and water vapor. With over 500 forming in the Florida Keys alone each year, and thousands more worldwide, waterspouts remind us that incredible natural phenomena are happening around us constantly. We just need to know where and when to look. If you enjoyed this deep dive into atmospheric science, make sure you're subscribed to this channel. Hit that like button, drop a comment letting me know what weather phenomenon you want me to explain next, and share this video with anyone who loves science and nature. Thanks for watching, and remember, the next time you see footage of a waterspout online, you'll know exactly what's happening and why. See you in the next video.